Python is one of the most valuable programming languages to learn today, known for its simplicity, versatility, and widespread use across industries. Whether you're diving into data science, automating repetitive tasks, or developing cutting-edge applications, Python equips you with the tools to solve real-world problems efficiently. Learning Python opens doors to countless opportunities in fields such as artificial intelligence, web development, and automation. At Pacta, our Python training is designed to guide you from beginner to expert, with a focus on practical applications. Don't miss out. Enroll now and empower yourself with Python skills that drive innovation. Ready to take your business to the next level with expert no-code solutions and strategic consulting? Contact Alan Stevens today for personalized guidance. Visit Pacta.com to learn more about how we can help you streamline your operations and protect your business. Don't forget to follow Pacta on social media for the latest updates, tips, and insights in automation, AI, and business development.
Ever accidentally multiplied a string in Python? Like 3 times A, please. And Python's like, okay, triple A, coming right up. It's kind of wild when you think about it, especially if you've ever run into, well, a different response doing that in another language. And that, my friend, is what we're diving into today. Those subtle choices baked into Python that make it, well, Python.
We're going deep, deep into the official Python 3.13.0 documentation, even taking the detour to Wikipedia to understand not just what these features are, but why they exist.
Because sometimes it feels like Python's doing magic, right? And knowing how that magic works, well, that's how you become a true Python wizard. So first up, let's shatter some myths, like the mystery of floating point numbers.
Ah, yes. The classic, why isn't 1.2 minus 1.0 exactly 0.2 lemma? It's a tale as old as time. Well, as old as computing, anyway.
It really does make you wonder. It's like Python needs glasses. Or maybe I need another cup of coffee.
Tempting to think so, but the root cause is, well, kind of elegant when you get down to it. See, computers, they think in binary, ones and zeros. Not exactly the best language for decimals. Like trying to fit a square peg in a round hole, sometimes you're left with gaps. And those gaps, well, those represent the tiny discrepancies you might see in those floating point calculations.
So it's not that Python's bad at math, it's just how computers fundamentally work.
Precisely. And it's one of those things you really need to be aware of, particularly, say, if you're building financial software, where a few decimal points off could mean, well, quite a lot of money.
Yeah, that makes a lot of sense. So what's the workaround? Because those inaccuracies, even if they're tiny, seem like they could cause problems down the line.
Awareness is key. Now that we know it's not some weird Python thing, we can anticipate those discrepancies, and, well, there are libraries for that, of course, like using the decimal library for more precise arithmetic, for example.
Good to know. All right, next myth on the chopping block. Immutable strings. Why is Python so against letting us change individual characters within a string? What's the big deal?
It often comes down to efficiency and, well, peeking under the hood at how Python handles strings behind the scenes. Imagine if you had a dictionary, right? But the keys could just, like, change whenever they felt like it. Chaos.
That's putting it mildly.
And immutable strings, they're like the guardians against that chaos. By keeping those keys constant, Python guarantees lightning-fast lookups, essential for tons of common operations. It's like each string gets a special ID card that never expires, making it super efficient to find them later.
So you're saying each time we change what appears to be a string variable, Python is actually creating a whole new string in the background.
Precisely. The original string, untouched, pristine, ensures consistency, predictability, all the things that make Python so reliable, especially when you're messing around with those data structures.
So less about being restrictive, more about keeping things tidy behind the scenes.
You got it. Python loves its elegant solutions. Immutable strings. Perfect example.
Gotta love it when a design choice that seems a little strange at first makes perfect sense when you see the bigger picture. Okay, this next one has always bugged me. Why doesn't Python have a traditional switch statement? Like you'd find in languages like C.
Goes back to Python's whole philosophy, really.
Right.
Readability, explicitness, all that good stuff. Switch statements, sure, they can be useful sometimes, but they can also get messy fast. Prone to errors if you're not super, super careful.
So it's not that Python's fundamentally opposed to switch statements. It just thinks there's a better way to do things.
You got it. Python's all about, hey, there's a cleaner, more elegant way to do this. Instead of a potential switch statement mess, you're encouraged to use, say, if else chains, or even, and this is kind of neat, Dictionary mapping for those multi-branching scenarios.
Okay, yeah, that makes sense. It's all about keeping your code clean, easy to read, less prone to those, wait, why is it doing that? Moments. Speaking of which, now that we've busted a few myths, ready to dive into some common pitfalls that trip up even seasoned Python developers.
Oh, yeah. Get ready for some of those infamous Python gotchas. You know, those moments where you're just like, why? Why is it doing that?
Oh, I know those moments all too well. Spend hours, days even, hunting down a bug only to find out, oh, it's a classic Python trap. Like, for example, lambda functions. So elegant, so powerful, until they hit you with that no statements allowed rule. Come on, Python, why you gotta be so picky?
Part of the grand plan, believe it or not. Lambda functions, they're designed for those quick, concise expressions. It's like Python's way of saying, hey, break it down. If it's getting too complicated for a lambda, maybe it's time for a separate function. Yeah.
So it's all about encouraging good coding hygiene, keeping things nice and modular, readable.
Precisely. Think of it as Python gently guiding you towards cleaner, more maintainable code. Now, of course, there are always, shall we say, creative workarounds. Like if you really need a statement in your Lambda, you could define a helper function outside of it and then just call that from within the Lambda.
Good to have those tricks up our sleeve. All right, let's move on to a real head scratcher. Mutable default arguments. This one, I swear, has cost me countless hours of debugging time.
A classic for a reason. Picture this. You define a function, right? And you give it a nice innocent list as a default argument. It's first time you call it, works perfectly, call it again, and suddenly it's like the function remembers what you did in that previous call. Spooky action at a distance, right?
Totally. It's like the list is haunted by its past, what's going on under the hood that causes this phantom behavior.
It's all about when Python evaluates those default arguments. And get this, it does it only once, when the function is defined, not every time you call it. So if that default argument happens to be, say, a list, well, any changes you make to it within the function, they stick around for the next call and the next.
So it's not creating a fresh new list each time. It's holding on to that initial one like a precious little snowflake.
Precisely. Imagine it's like using the same sticky note over and over again. You write something, erase it, write something else. But those faint traces of what you wrote before, they're still there.
Okay, that analogy really drives it home. So how do we avoid this sticky note nightmare?
Easy fix, actually. Instead of using the mutable object directly as the default argument, you use none. Then inside your function, you check if the argument is none. If it is, you create a brand new instance of your list, dictionary, whatever it is. That way, you're guaranteed to start fresh every single time.
So basically, don't reuse sticky notes. Always grab a fresh one. Makes perfect sense. Pitfalls successfully navigated. What's next on our Python adventure?
Hidden gems, my friend. Those elegant, often overlooked features that can really make your Python code sing. And trust me, Python has a whole treasure chest of them tucked away.
Hidden gems, you say? I'm all ears. Let's sprinkle some of that Python magic onto our code. Hidden gems in a programming language. I like the sound of that. Feels like we're about to uncover some Python treasure.
Let's kick things off with a seemingly simple one, the is operator. You might be thinking, hold on, don't we already have double equals for comparisons? And you'd be right, but the is operator, it brings something unique to the table.
Okay, color me intrigued. Double equals, that's for checking if two things are equal. But what's is checking for then?
Think of it this way, double equals. It's like checking if two things have the same information on their driver's licenses. But the is operator, that's like making sure they're actually the same person.
So what you're saying is two variables, they could have the exact same content, but still be stored in different places in memory, like twins, but with different addresses.
Exactly. They might look identical at first glance, but the is operator, it can tell they're actually distinct entities. And this is super useful when you're dealing with singletons like none, because there's only one none object in the entire Python universe, right? The is operator, it gives you that definitive answer, often even faster than double equals.
So, rule of thumb, when in doubt, use is for comparing against none. I'm adding that to my mental Python cheat sheet right now. What other hidden gems do we have in store?
Let's talk about super. Now, this one's a lifesaver in the world of object-oriented programming, specifically when you're working with inheritance.
Right, inheritance. That's when you create a new class based on an existing one, inheriting all its, well, its personality traits, so to speak. But where does super fit into all of this?
Think of super as a bridge to those inherited traits. Like, imagine you have a subclass, and it needs to call a method from its parent class. Now, instead of copying and pasting that entire method or, reinventing the wheel, super swoops in. It's this elegant way of saying, hey, parent class, do your thing. Keeps everything nice and tidy.
So it's like a shorthand way of calling a parent classes method without having to, write out all the code again. That's pretty click.
Exactly. It's all about keeping your code DRY. Don't repeat yourself. It's a much more structured, more elegant approach to object-oriented programming. And speaking of clean and efficient code, we can't forget about Python's list comprehensions.
Ah, yes. List comprehensions. They're like the shorthand of Python. They take what could be multiple lines of code and condense it into a single elegant expression. It's beautiful, really.
It's the embodiment of Python's design philosophy in action. Readability, conciseness, it's all there. Instead of writing out this clunky for loop to, say, create or modify a list, you can often achieve the same thing, maybe even more efficiently, with a single line of code. A thing of beauty.
It's like choosing between writing a long, rambling email and a concise, to-the-point text message. Both get the message across, but one is definitely, shall we say, more elegant.
Couldn't have said it better myself.
Oh!
Now, before we wrap up our Python deep dive, I think it's important to take a step back, appreciate the bigger picture. All these design choices, the quirks, the elegant solutions, they all stem from Python's core philosophy.
You're talking about the zen of Python, right? Readability, explicitness, beauty. It's like Python has its own philosophy book.
And it really shines through in every aspect of the language. Python was designed to be both powerful and enjoyable to use. And that joy, it comes from writing code that's easy to understand, easy to maintain, maybe even, dare I say, beautiful to look at.
It's the difference between navigating a well-organized library and, well, getting lost in a messy attic, right? Python, it strives to be that well-organized library, even when you're dealing with really complex concepts.
Absolutely. And a key part of that organization is the choice of implementation. Now, we've mostly been talking about CPython, the standard implementation, the one everyone knows and loves. But it's important to remember that alternatives exist.
Right, like PyPy. I've heard whispers that it can significantly speed things up. It's like a turbocharged version of Python, right?
You could say that. PyPy uses this neat trick called just-in-time compilation. And yeah, it can lead to some pretty impressive performance gains, especially for those heavy-duty computational tasks. But it's not a silver bullet. You might run into compatibility issues with some libraries, and, setting it up can be a bit more involved.
So, like with most things in life, it's about choosing the right tool for the job. CPython, that's our trusty workhorse for everyday Python tasks. Py. That's when you need to unleash the raw power, but you got to be prepared to put in a little extra effort.
Precisely. And then there are others, like Jthon and IronPython, each one tailored for specific needs and integrations. It's really quite fascinating when you start exploring these different flavors of Python. Opens up a whole new world of possibilities.
It really is remarkable. We started with this language that's designed to be simple, fun, beginner-friendly even, but then you peek beneath the surface, and there's this incredible depth, this whole universe of possibilities waiting to be explored. We've gone from debunking myths to dodging common pitfalls, and now we're uncovering hidden gems and exploring different implementations. And through it all, we've kept that core Python philosophy in mind: readability, elegance, and a touch of magic.
And the beauty of it is, this is just the beginning. Python is a journey, not a destination. The more you learn, the more you discover how powerful yet elegant this language truly is.
It's like we've unlocked a secret level of Python understanding. So to all you listeners out there, keep experimenting, keep exploring, and most importantly, never lose that sense of wonder. There's always something new to discover in the world of Python. Until next time.
Ready to take your business to the next level with expert no-code solutions and strategic consulting? Contact Lance Stevens today for personalized guidance. Visit Pacta.com to learn more about how we can help you streamline your operations and protect your business. Don't forget to follow Pacta on social media for the latest updates, tips, and insights in automation, AI, and business development.